Hello everyone, we are Team SPECTERS. Our problem statement ID is 1448, that is design of RF up-down converter from CKU to L-band by using GNU Radio and SDR. This problem statement is given by NTRO under miscellaneous bucket. The primary aim of this project is to harness the capability of GNU Radio and SDR to create a versatile and open source RF up-down converter by addressing the specific need of satellite communication and by ensuring signal compatibility and quality across different frequency band. The problems encountered in traditional RF converters are that they are designed for specific frequency ranges and not adaptable to different frequency band without significant hardware modification. This leads to problems such as limited bandwidth, high power consumption, and very high cost. To solve this problem, we will use GNU Radio and SDR, as all the parameters will be controlled with the help of software. Our solution is the use of GNU Radio and SDR. GNU Radio, with its efficient software, allows flexibility. SDR can support wide ranges of bandwidth and frequency bands. It allows users to change frequency band. SDR reduces phase noise with set algorithms. It gives better performance and adaptability as hardware and software works in tandem. Let me take you to our implementation part where we used Matlab and GNU Radio to simulate our algorithms.
Initially, we began working in Matlab as it was a tool already familiar to us. Here is the Matlab code in which we first provided the input image and embedded it into the carrier signal. Later on, we upconverted the image using an upconversion algorithm. We attempt to recover the original image using a downconversion algorithm, in which we were almost successful with the some noise issues. We are working on mitigating that issues. The output of this code consists of 6 components. That is, the first one is the carrier signal. The second is the L to C band conversion. The third component is the original image. The fourth is the upconverted waveform. The fifth is the downconverted waveform. And the final component is the received image. From this, we concluded that we obtain near about the same images as that one initially provided as the input.
After our basic understanding in Matlab, we moved on to GNU Radio and simulated similar test scenarios.
In this setup, we initially use the signal source block to generate the carrier signal and the audio source block to import the .wave audio file as the input. Then we combine these two signals by using a multiply block and display the output using the QT-GUI frequency sync block. Here you can see the output, which is the original audio signal superimposed with the carrier signal. In this setup, we later introduce the signal source block for modulation. We then multiply it with the previous signal and the output of this multiplication is fed into a high-pass filter for upconversion. The resulting signal from high-pass filter is then directed to the QT-GUI frequency sync block for monitoring the output. Here you can observe the output of the upconverted audio signal. In the downconversion process, we initially use the same blocks that were used for the monitoring the output of the audio signal. Later, we further modify this block by adding signal source blocks and modulating them with the previous output. The resulting signal from the multiplier is then passed through a low-pass filter and the output of the low-pass filter is directed to the QT-GUI frequency sync block for monitoring the output. Here you can observe the output of the downconverted signal.
The conclusion part. First of all, with the help of Matlab, we have successfully up-down converted audio and image data. Later, up-down conversion of an audio signal are simulated by using GNU Radio. And the most important part, the future scope of our project. We will be working with the appropriate SDR hardware and will use SDR USRP source block in GNU instead of signal source block to create an open source RF up-down converter for satellite communication. Thank you for your time.